gas and be like, oh, I still got the gas. No, that gas is gone. It's escaped. So it's like not even a valid test. Just putting that out there.
Yeah, I don't know. Have you ever been like in a narrow valley in late autumn or winter time?
Before we go on to another scenario, if you fill a container up, a balloon, a container, whatever you fill up, there's going to be a gradient in it. All right. Yeah, I know someone said earlier it would equalize and be equal, equal everywhere, but there's always a gradient, isn't there?
Yeah, there is.
Oh, I thought you said it was going to just equalize earlier.
No. What I say is if there's no gravity, nothing acting, or no force acting on the atmosphere, the problem then is to explain why we can have 10 psi pressure difference over just 8,000 meters in the vertical.
Because there's a gradient.
Yeah, but what's causing that gradient?
It could be heat, could be all the gases are coming from the surface.
No.
Could be a bunch of things. Yep.
And there's an electric gradient on the Earth.
There's an electric gradient on the Earth. There's so many reasons why there could be a gradient there. I don't know what to tell you.
The composition of the air at Mount Everest is the same as at sea level. It's just less.
There's an electric gradient on the Earth.
The electric gradient?
Yeah.
Yeah, there is.
Yeah.
Okay, you know how much this can vary during the year?
Did you know that the gradient is a characteristic or quality of the pressure? And so this is a non sequitur and a red herring when someone's asking you about the antecedent of the pressure itself, to then just invoke delta pressure, the change in pressure. Right, because pressure is X, and you're just talking about delta X. It's just a red herring fallacy.
No, it's not.
It is.
No, it's not.
If someone says that the necessary antecedent to gas pressure is physical containment, and then you reply by saying we have a gradient, it is by definition a red herring fallacy.
No, it's not.
Can you define red herring?
If you have two chambers connected with different pressures, as you open that valve, the pressure will equalize. In the vertical direction, in the atmosphere, that doesn't happen.
So once again, if someone's talking about the actual antecedent to have the gas pressure, and you invoke a gradient as a rebuttal, it is a red herring fallacy, because no one is talking about the gradient. In order to have a gradient, you have to have the gas pressure in the first place. So the point that we're talking about is, how do you have the gas pressure in the first place? Do you think it's somehow a sufficient answer to that question by saying there's a gradient? Okay, that's a cool story, right? But where gravity is the strongest,
it's one of the weakest.
You see what you're doing? This is why you shouldn't interrupt so much. Because you have no idea what you're talking about. I said where gravity is the strongest, and you jumped in to say, no, it's weak. Shut up. It's the strongest at the surface in your paradigm. It is the strongest closest to the center of mass. Okay, so gravity would be the strongest at the surface. Yet at the surface, if we have gas pressures close to a vacuum, it will fill the available space. So gravity doesn't prevent it from filling the available space where it's the strongest. So why would it prevent it from filling the available space where it's weaker?
Yeah, because the heavier stuff are pulled down, so it's buoyancy. Does that make sense?
No, the composition of the atmosphere is the same at the surface as it is at top of Mount Everest. Percentage-wise, it's just
gravity doesn't stop gas pressure from filling the available space at the surface. So why would it do it where it's weaker?
How much weaker is water? Hang on. How much weaker is the gravity on the top of Mount Everest than at sea level?
Doesn't matter how much. It's
yes, it does.
Why are you
because it's minimal
me again, dude?
Yeah, because you didn't let me finish. And
you asked me a question.
And In addition, you have all the mass of Mount Everest as well, which increases the slightly the gravity.
Dude, this dude asked me a question. I began to answer it. He then interrupted and said, "You didn't let me finish."
A two-part question.
Yikes.
Yeah,
And then
he's been
someone in the
doing
chat's
that.
telling me to grow up. What a joke. So gas pressure
Put it disrespect.
has an antecedent. That's a physical container. Okay. You're just skating past that, talking about the gradient and invoking gravity. I'm explaining to you that in your paradigm, gravity is the strongest at the surface, and yet it does not prevent gas pressure from filling the available space. Where is the strongest? It is weaker further away. So how would it all of a sudden prevent it from filling the available space? Your response is, how much weaker is it? In the grand scheme of things, not significantly weaker, but it is still weaker. So it's just the fact that it is weaker. It doesn't matter if it's 0.1% weaker. It doesn't matter. It's weaker. You're claiming it's going to do something that it doesn't do where it's stronger.
So the reduction of gravity by vertical height is the reason we have the pressure gradient.
Then
What-
why can gravity not prevent gas pressure from filling the available space at the surface where it's the strongest if you're claiming that it's going to stop the gas pressure from filling the available space where it's weaker?
It doesn't stop. It again. It pulls everything towards the center. That's what it does.
That's
So
not even what gravity does in your model anymore. Gravity
of course
doesn't
it does.
pull anything.
Absolutely does.
Gravity
It
doesn't
does.
pull. No, gravity doesn't pull anything
No,
in
no.
your model. No, you don't even know your own model.
Absolutely. No,
Yeah,
you
dude, are
don't
you
know
talking
our
about
model at all.
Newtonian? Are you
Yeah.
talking about Newtonian gravity or Einsteinian gravity?
Both of them have the
They're two.
gravitational.
No,
Both have
no, they're completely
gravitational.
different. They're not the
They
same
both
thing.
have
Einsteinian gravity
gravity.
debunks Newtonian gravity in your paradigm.
Brother, you
No.
think it does. That's you guys. That's
No,
you
no,
Why did
guys.
no.
Einstein
That's
have to
you.
come out with a special theory of
No,
relativity
you
then?
don't understand. What you guys did was heard one guy talk about gravity, you heard another guy talk about it, and you're like, oh look, it's debunked over here. And no, both of them have the
Dude, we can
gravitational
quote countless
constant.
PhDs
Go
in your
ahead.
own paradigm
Go
who
ahead.
have stop
Go.
interrupting so much, bro.
You interrupted me, brother.
No, you're like just screaming. Every time that you talk in here, you just start yelling.
Because people are talking over me. You guys talk over me, and then you complain when I talk over you. Why? Why do you guys do that?
That isn't what happens. What happens is someone tries to go back and forth with you, and as soon as they go to respond to you, you start talking again. And it's always in the form of screaming.
No, brother, I was talking. He jumped in and he said, hey, you don't even know your paradigm. And you went on. And I was trying to get my words in. Please, guys, you have to know whenever you do wrong, you have to recognize that. Humble yourself, man. We
The
are
irony.
humble people. Come on, man.
The irony.
We're
irony.
very humble, man.
Okay, so you don't understand your own belief if you think that Einsteinian and Newtonian gravity are the same or that they are both true. They are not. This would violate the law of non-contradiction. I'll give you some examples. Einsteinian gravity says that gravity is not a force. Newtonian gravity says gravity is a force. Newtonian framework says that space is absolute and fixed. Einsteinian's framework says space is not absolute and fixed. The Newtonian framework says that there must exist a medium akin to an ether. Einsteinian's framework says there is no ether. The Newtonian framework says that there is no time variable. It's effectively instantaneous action at a distance. Einsteinian's framework specifically accounts for a time variable and claims that it slows down. One claims that it is the inherent property of mass, an innate quality of mass, that it's the direct cause of the phenomena that you're attributing it to being it's a force. While Einsteinian says it's just the effect of the bending and warping of space-time, it's an emergent property. It isn't a force. These are fundamentally opposite. The door can't be open and closed at the same time. It violates the law of non-contradiction. So if Einstein says gravity is not a force, and Newton says gravity is a force, they cannot both be simultaneously true. I'll give you
I
another
think he
example.
says it's not a force, but it acts like a force.
Okay, so they're not both simultaneously true. And Newton says that an object will continue in a straight. Newton says that an object will continue in a straight path unless an outside force acts upon it. Plus, I think you're hot micing low.
Lush.
Oh, sorry, man. Damn it! Why do I always do that?
Newton says an object will continue in a straight path unless an outside force acts upon it. Einstein says an object can go in a straight path and a curved path at the same time and doesn't need an outside force to act upon it to make it deviate from that straight path. Those are literally opposite claims. This is what we mean when we say you guys don't even understand what you
when
believe.
you were talking about, can I just double check? You said Einstein says it can go straight or curved. Are you talking about geodesics?
Dude, you can say that as an example. Sure, that from a singular reference frame, it's a linear path, and from the other reference frame, it would be a geodesic path, which is the straightest path on a ball or a curved space. That is not, you don't seem to understand the point, though. The point is that
I was just trying to clear it up, what you meant by straight or curved.
Newton says an object will continue in a straight path unless an outside force acts upon it. Einstein says it does not require an outside force to act upon it.
Because Einstein said it does not.
Yeah, he said it does not require an outside force to act upon it. It says that space itself will curve and that the object will free fall in a linear path from its reference frame. But if you were to zoom out from another reference frame, it would be curving and that no force is acting upon it to make it curve.
Yeah.
Newton said that space is absolute and fixed, and that if there's an object that's curving, it can only do that because an outside force is acting on it.
And where does a locality come into this?
Address the point. You agree that those are opposite claims?
I don't care.
So then they can't both
derive. You can derive Newton's. You can derive Newton's formula from Einstein, and even Einstein said he didn't debunk Newton.
That isn't true. That isn't true.
Yes, it is.
I can quote. No, I can quote Einstein.
Yes, I can. So can I. Not for the time being, but I can.
I know the one quote that you guys all take out of context, talking about him saying that this can't be interpreted at what he's saying. What he literally says in the quote that you guys don't understand is that this cannot be taken as to remove the historical importance of Newton's discovery.
Oh,
that's what he literally says. No,
exactly.
That's what it says.
What we're trying to say to you is that
what you're trying to say is that he claimed they're both still true. That isn't what happened.
A manifestation and interpretation of how gravity works. They're both in line with that.
No, they're literally opposite.
Explaining it. They both have the gravitational constant in them, brother.
Okay, this is what I'm saying. You guys just lack comprehension skills, man. Math is not synonymous with science. Okay, whenever do you see you see how every single time you interrupt? Do you notice that it's every single time that I talk?
Why would you say that though?
Look what you're doing. So math describes things. Science explains things. So I can describe, say the object falls at 9.8 meters per second squared. I can describe that with math. I can actually use a kinematic equation to describe that. I can use height, initial velocity, and distance. And I can tell you how fast it's going to fall. I didn't use any forces, any dynamic claim at all. So we can mathematically.
Could you repeat that again?
Yes, you could.
How did you start?
Height, initial velocity, and time will give you the rate of fall, 9.8 meters per second squared.
But not acceleration. No, you can't have an acceleration without adding a force.
So you don't see. This is what you don't understand.
Are you actually saying you can have an object? You can have an object accelerating without. Well, you don't necessarily need to call it a force. We could call it a curvature of space-time, which gives the effect.
Yes,
Okay.
dude. Every time you drop, hold on, real quick. What's it? Every time you drop something, you have mass accelerating with no force. And like you said, if you have mass accelerating, you need a force. That's what Newton's second law said. But Einstein came along and said, no, we can have mass accelerating. It happens every time you drop something with no force.
Yeah, can you quote
It's,
who are the people in their own paradigm, like their priest class, that have said it like very blatantly that they replaced on Newton?
so let me see
I'm
if I got
asking
this
Jeremy a
correct.
question. Jeremy, you remember?
Feynman. Hold on, guys. Feynman and Shanker. Both.
And then who's the
So,
girl? Is the girl Shankar?
Andrea Ghez, 2020 Nobel Physics Prize winner. She did her work on black holes. She came back and said we can totally rule out Newton's law of gravity. Laws are supposed to happen everywhere, and it's not
You can let
happening
go of the
here.
helium balloon and rule out Newton's law of gravity. You don't need to go to a fake black hole to do that.
It's just
No,
physicists claiming it.
Yeah,
It's a Nobel Physics Prize winner.
I'm gonna help you out here though. You repeating like the FED talking point is not good. So like saying that because
with it.
Yeah,
Go
I'm about
ahead
to
and
teach
say
you.
gas. Yeah, go ahead and say gas molecules have directional bias. Then
Watch this. Watch this. How funny this. This is such a bad argument. So just because an object goes up, that does not eliminate the possibility that there's a downward bias. Okay, so this is such a simple concept. It's such a terrible argument that you guys make. If I have a ping pong ball and a golf ball, I'm going to drop the ping pong ball in the. Yeah, listen. I have to get as elementary as possible, apparently.
Yeah,
If
ping
I
pong
drop
golf ball. Go ahead.
Okay, if I drop the ping pong ball in the water, it floats. If I drop the golf ball, it's going to sink. Okay, right? Okay, so I'm going to take this golf ball and let's just drop it in the air. Boom. It's going to fall. So the golf ball is more dense than the medium, so it falls down. Do we agree?
Is helium and golf ball the same thing, or are they different states of matter?
You didn't answer the question? You see how you didn't answer the
different
question?
states of matter, Witsit. Gases don't have directional bias.
Watch this, guys. This is what the whole FED has to do. He's going to do that for this entire conversation. So,
what? Just remind you that gases and ping pong balls aren't the same matter.
I didn't say that they were. So the golf
this is a false equivalence, then?
No, I'm not equivocating them. You're just not following the analogy. So
listen. Hold on. Let me before you go into this, because I'll listen. But all I've merely been trying to state is that there is no directional bias with gas. I don't understand why everyone finds that so confusing.
Yeah,
like right here, it literally says gases are composed of molecules that are in continuous motion, traveling in straight lines and changing direction only when they collide with other molecules and with the walls of a container.
Can you
just stop? The particles move rapidly in all directions, frequently colliding with each other in the sides of their container. With an increase in temperature and particles, gases gain kinetic energy and move faster. The molecules of gas are free to move about in any direction. There's literally no downward bias for a gas molecule. Gas molecules don't prefer to go one direction. They go any direction they possibly can until they collide with something. Therefore, there's no force of gravity acting on gas, which is mass. So
now notice how I just let this guy say all that after he interrupted me, and he still isn't going to let me say it. He's still going to impulsively interrupt me again for the fifth time.
You want to talk about ping pong
He's already
balls
doing
and
it. He's already doing it. You have no self-control. Steve, no one needs to jump in and start interrupting also. What are you doing?
Vax, just let him speak, please. Just let him speak.
Okay, if I drop a golf ball in the air, it's going to go down. It's more dense than the air. That means it has a downward bias. It has a tendency to go down, a preferred direction. It goes down because it's more dense in the air. It's going to go down. Okay, do we agree? Yes or no?
No, we don't.
Okay, Steve doesn't agree. Don't care. To the FED guy.
Oh, really?
How about this? Can we define downward bias? What does downward bias mean?
Down is not a nebulous thing. Down is caused by something.
Non sequitur. What
is down? It's in relation to a horizontal. You can only have down based off horizontal. But I mean, that's again whatever.
Down is not
another non sequitur. Another non sequitur.
Is down a thing? No, it's not a non sequitur. Stop saying those words. You guys
He
have
was
these
saying
words
that
that
to
you
me.
use to try to make yourself feel as if you're so great. Stop that. Down is not
No,
a
I'm just
nebulous
gonna
thing.
mute you for the rest of the day if you don't
Please,
stop
please.
interrupting me.
Brother, you interrupted me.
No, I didn't.
You
So
asked a
very
question and I answered, remember? I was
yeah, and then
speaking
I
and you
went to ask the
interrupted.
other guy, and you just keep coming off mute, yelling over everyone. You have no self control. So
Oh, I'm perfectly in control, brother.
well, that's way worse. That means you're intentionally being incredibly disrespectful. So this is
Funny.
very simple. I'm going to drop a golf ball in the air. It's going to go down. So everyone's saying, oh, gas goes in all directions. That means there's no downward bias. This is a very stupid argument because that is not mutually exclusive. So let's talk about it very simply, step by step.
It
What
is with
if,
gas,
now,
Witsit.
if you're claiming something doesn't have a downward bias, then you must obviously have a definition of what that means. So define downward bias.
A
Okay.
preferred directional bias down would be a downward bias. An
Okay.
object that prefers to go down and not randomly in all directions.
Okay,
What
cool. Okay.
direction does gas move in?
Dude, just stop. We don't need you to repeat your stupid religious script. I've heard it for 7 years. Stop.
Witsit, what direction does gas move in?
Dude, all directions. Now stop interrupting me.
So no
Hey,
downward bias with gas, right? Can we just be clear on that? Does gas have a Witsit, does gas have a
No,
downward
no,
bias?
no
Yes or
bio
no?
direction. No.
Do I have to mute you?
Witsit, does
Do I
gas
have
have a
to mute
downward
you?
bias?
Do I have to mute you?
Just answer the question. Does gas have a
I'm
downward
trying.
bias?
You're not gonna. This is how it works. You don't get to just interrupt and talk all over me and start forcing me to answer your new set of questions.
Does gas
Stop.
have? It's not a new set of. I've been asking
Dude,
this
he can't.
question
He
since I've
literally
been in
can't help
here.
himself. None of you can help yourself. You have. You need to
Does
work
gas
out
have
or
a
something.
directional bias?
Learn.
You're
Learn
repeating the
discipline,
same
man.
question, bro. Come on, shut up, shut the hell up.
Okay.
You already asked your question. Don't have to repeat it 10 times.
So this is important to understand. So he just said a downward bias is a preferred direction down. Correct. That's all that that phrase means is that there's a preferred direction and that that preferred direction is down. Okay. Does a golf ball that's more dense than the air have a downward bias? Yes or no?
Golf balls don't think. Down is not a nebulous thing, Witsit. Come on,
Oh
brother.
my God. Steve,
Sorry, I can't.
I'm
I
not
can't
talking
listen
to you.
anymore. Goodbye.
Bye. Steve, stop interrupting or I'm muting you. To the other guy, very simple question. Based on your definition, a golf ball we know is more dense than the air, so it's going to go down. So does the golf ball have a downward bias?
What if the golf ball is filled with aeon?
Why can't you answer the question? Does the golf ball in the air have a downward bias? Yes or no?
Of course, the golf ball is going to seek equilibrium on a surface to where it's no longer moving. Does gas do that
So
too?
yes. So your answer is yes.
Okay, sure.
Okay, the
Golf
golf ball has
balls
a
don't
downward.
levitate in the air.
Look, dude, the golf ball in the air has a downward bias. Okay, cool. Now, if I were to introduce acoustic levitation to the golf ball, it's still in air. It's still more dense in the air. It still has a downward bias because it's more dense in the air. But I've now introduced an additional variable, acoustic levitation. Now, the ball, once I let it go, it's sitting there floating because I've actually manipulated the medium with sound waves, and that vibrational displacement has caused the golf ball to levitate. So that doesn't mean that the golf ball doesn't still have a downward bias. It does. It's still more dense in the air. It still has a preferred direction, which is down. What we've done is introduce an additional variable that overcomes that bias and makes it go up. Therefore, that very simple concept should not be disputed ever again. So it isn't proof that there is no downward bias just because something isn't currently going down.
That's when I asked, does gas have a downward bias? Yes or no?
They do not just get the point. I'm not making a claim about whether or not gas has a downward bias. I am showing how your claim that it is proof there is no downward bias because gas goes in all directions is ignorant. It is a very stupid claim. The
No,
fact
it's
that
proven that gravity is not a force acting on matter.
did you not just hear what I explained to you?
What's it? Gas moves freely in every random direction, correct?
Yes.
Right, so what's the point?
Okay, let me give you an example. There's something called ionic wind. Okay, the air.
What is ionic wind? What's it made out of? Gas?
Yes. And guess what? It has a preferred direction relative to its charge. It's called ionic wind. In fact, we actually can run generators off of it and generate electricity with it.
Barely.
Wait a
Doesn't
second.
matter.
Oh,
Barely?
it's
Why
charged.
is everyone so why do you people operate this way? What
Because
does
you're wrong.
barely? How does barely somehow rebut my point?
The ionic wind is a very fragile, weak phenomenon that
What's the
requires
relevance of
high
that?
voltage and very good air conditions. It doesn't work when the air is the least bit damp. There's no
What is the
way it's
relevance of
relevant
that
to
point?
this because it's not a force that's strong enough to do anything with the density of a golf ball.
Oh my God. No one's talking.
Acoustic levitation as well. These examples you're bringing up are just trying to confuse the issue, and they can't support the mass of attraction of a golf ball against a
What?
force that is
So you
commonly
don't even
called
comprehend the
gravity.
point at all. Then that's what's
Could
happening.
I
Okay.
ask a question to
I-
try to understand the concept?
I comprehend that you're throwing out confusing concepts to
If you,
confuse the
well,
discussion.
thanks for letting us know that you're confused with these elementary concepts. Maybe go
That's
on
not
mute.
what I said. You know that.
I
Ionic
have a
wind is an
question to try to
elementary
clear something
concept.
up.
Okay.
So,
Why is everyone
so
so
are
bad
we
faith nowadays? Michael, go ahead.
are we discussing? Are we trying to figure out like why if the Earth was in a vacuum chamber and there's no enclosure, why the atmosphere, the gas in and the atmosphere doesn't just why it stays why it stick on the
Because
Earth
it's the
or
second law of
Well, I'm
thermodynamics.
actually
The
trying
gas
to
is
I'm
called a
actually trying to
vacuum.
help the flat earthers out who are all religiously repeating the script from FED, and the argument is
Okay,
very
ping pong
bad.
golf ball.
Although the conclusion may be correct, their argument is fundamentally fallacious and ignorant. So the better argument is that, for one, you can't just blindly invoke gravity, assume its existence, affirm the consequent, reify the concept, and then claim it's doing something that it doesn't do, where gravity would allegedly be the strongest. That's the actual argument, is that the second law of thermodynamics necessitates that there's physical containment, that to have gas pressure to prevent it from filling the available space. But to say that because gas goes in all directions, that proves there is no downward bias is really stupid. There could be a downward bias and an object can still go in different directions, including up. Just like I said, I can use a Van de Graaff generator, I can use acoustic levitation, I can use magnetic levitation to make objects that do have a downward bias. They're more dense than the medium, and we just agreed that means they have a downward bias, and I can make them go in all directions because I've introduced a stronger force. Okay, so what that means is to make the claim that the fact that gas goes in all directions disproves there's a downward bias is dumb.
Oh, I'm sorry,
Yeah,
Witsit. My bad.
that
My
makes sense.
bad. I see the light now. So everything has a downward bias except for gas, right?
Oh my God.
Vax, that's not what he's saying. That's not
It
what
does
he's
have a
saying.
downward bias in a way, doesn't it?
You're not understanding the concept.
Is there a video of a golf ball levitating with acoustic or ionic wind levitation? I'd
I never
really
How
said
did
like
it
to
that
does it
know.
with
go?
ionic wind. You didn't even understand the concept. I brought up ionic
Yeah,
wind to
why
say,
did you
like,
bring it up?
yeah, maybe you should listen more. So I brought up ionic wind in the context of saying that gas isn't affected and goes in all directions. I said, actually, gas will have a preferred direction relative to charge. Ionic wind is an example. Also, you can touch a Van de Graaff generator and you can reach a point at a candle across the room and make the candle go out. Okay, because the static charge does affect air. Okay,
And
so
how
when
many
you
volts
introduce,
are
it
required to do
doesn't
that?
matter.
It does matter. Numbers matter, man. You're making
No,
claims about physics.
Guys,
no, it
Witsit,
doesn't matter.
what I see here is that Witsit, Austin, knows a lot about electrostatics, and he's trying to get a point across about a concept, and you guys who don't know anything about electrostatics, maybe like a bit, are trying to tell him how it is and saying that specifics matter. He's trying to get a concept across. You guys are not understanding that concept. You're trying to pick on details. He's trying to get a concept across. Like, open your mind, open your eyes, and understand the concept he's pointing to. Okay?
Correct.
Will somebody consider the possibility that some of us actually might know a little bit about electrostatics and
A little bit
like
is different than a lot. though.
I'm understating my knowledge because
Well,
I'm
you don't seem to be able
not
to follow the
an
concepts.
arrogant boaster. No, I can, and
Okay, Stillman, my
you're
position,
invoking
Marsh.
things like, okay, you're claiming that ionic wind can be produced by things such as a Van de Graaff generator, which can blow out
No,
a candle across the room, and
no.
this is an example of a thing that does not happen very often in daily life, so it cannot explain the things that we see in the daily life, like say the downward bias, as you call it,
Oh my
which
God.
sounds a heck of a lot like gravity to me.
Okay, look, so I just asked you to stillman my position because you claimed you understood it, and I know that you don't. You then proceeded to combine three different examples, completely bastardize it, then strawman me, and then argue against the position before you finished. Do you not know what a stillman is? A stillman is where you
I
present the
repeated exactly
strongest.
what you said, man.
Really, I said that I was trying to conflate gravity and electrostatics to explain the downward bias. That's what I said?
Yeah,
Really? Yeah.
Mike,
So
why don't you explain
this
what you're saying again?
okay. First of all, I'm going to explain to you what a stillman is. A
I
stillman
know
is
what
where
that is, dude.
well,
We all know what that is.
you definitely aren't
But
able
it's
to
not
do it
being
apparently.
patronizing, dude. I'm sure he knows what a steel man is, dude. Don't be a dink.
Well, it doesn't matter.
He's
Like
the
you
one that
guys just
jumped in
listened to
being
him.
patronizing.
What?
Actually, he
No,
jumped in being
I
patronizing
don't
5 times.
politely
You,
disagreeing that I'm not being
that's not
patronizing.
what you did. You said you were just trying to use confusing concepts so that you can confuse everyone and they don't know what's going on. You didn't ask simple, good faith questions.
Where I come from, that is a polite disagreement with relative to the kinds of things that you're claiming.
So
Okay.
guys,
Well, okay,
who
look, this is
cares
a
if you
polite
know what a
disagreement.
stillman is?
You don't.
Who
Well,
cares
okay,
if you know what a? Go ahead.
I want to explain what a stillman is because it's important. So, a stillman is where you present the strongest form of the other argument that you can. It doesn't, in fact, that means that if you can think of a stronger one than they have made, that you actually even make it stronger. At the least, you accurately represent their position and make the strongest form of that argument. That does not mean changing it to make it as weak as possible so that you can beat it up. That's a straw man. That's the opposite. The reason I asked you if you can still man it is because it's the fastest way to prove whether or not you're actually listening and understanding what's being said prior to claiming that you're going to refute it. Because it's just a waste of time. Now you didn't
Can we
understand it.
talk
I'm going to
about
explain it one
ideas
more
and
time.
not people? Well, I want to hear about ideas
Dude.
and gravity and not people.
Oh my God. Okay, so this was the actual point. When the ionic wind was brought up, it was just used as an example of how gas does have a directional bias when an additional force is introduced, such as charge in that example. This is not a phenomenon that can be disputed. It can even be used to generate electricity with certain generators. I brought
Okay,
up
I'm question. I just want to take it one step at a time. I'm hanging out in my house right now. Is ionic wind a thing that is happening?
in your house.
Yeah, right now in everyday life, is ionic
Yeah,
winds a normal
outside
thing?
your house, it's happening in.
But not inside? Do objects fall
I,
down inside differently than
this
they
has
fall
nothing to do
down
with
outside?
objects falling down.
Okay, so all this talk about ionic wind has nothing to do with the downward bias you're talking about.
Back to the point of you not listening and understanding what I'm saying. So,
I'm trying to
I'll,
clarify what you're saying. I'm
well, then you should
asking
just
good faith
listen.
questions here.
The only reason, listen, the only reason that I brought up ionic wind was to make the specific point that gas can have a preferred direction, and ionic wind is a perfect example of that.
So something has to happen to the gas for this preferred direction to take place. It's not just something that naturally happens to all gases. Something has to take place for this direction to change. What's it?
Yeah, high voltage charge.
Well, so
Right.
first of all,
So
everything
if there
does
is no high
naturally have a
voltage
charge.
charge, if there is no high voltage charge taking place to this ionic, causing the ionic wind, then there would be no directional bias with the gas.
Wait, okay. So you do understand the point now, though, which is that it is a very bad argument to say that proof there is no downward bias is that gas goes in all directions. That is a very poor argument because
Is that not the case?
because an object, including gas, can have a downward bias and still go in different directions. Those are not mutually exclusive, because if what's causing it to go in a different direction is stronger than whatever is causing the downward bias, it will overcome it. That doesn't mean the downward bias no longer exists. When I make the golf ball levitate with acoustic levitation, the principle of density didn't cease to be true. It didn't all of a sudden stop having density. It didn't all of a sudden stop having a downward bias because it's more dense than the air. It was just overcome with an additional variable. So please stop saying the argument that we can prove there is no downward bias because gas goes in all directions. That is not a good argument.
Oh yeah, yours is so
Can I
much
steel
better.
man
Yeah,
that?
I'm just gonna chant ping pong golf ball anytime someone says that gas has a directional bias now, right? That's the way that flat earthers should be going. Ping pong golf ball density. Dude, unless the gas gets charged, until the gas gets charged, there is no directional bias for that gas. It's moving wherever it feels like, wherever it can. Just because something happens, like a lightning strike, hits a fucking flagpole and causes ionic wind around that flagpole, that doesn't mean that all of a sudden now gas does have a directional bias.
All right, so
But
Vax. So
can you
first of all, I
explain
don't.
this downward bias thing again? Because I don't really get it. I mean, like
Well,
a
Michael's
helium balloon goes up, but Bohr, like a heavy gas, is down on the floor of a bucket while there's normal air around it. So why
So
has air no or any directional or not directional bias? I don't get that directional bias. Never heard about that.
Sure, that's kind of
so
like if you have a fish tank filled with sulfur hexafluoride, right? And they'll get the little aluminum, like they'll make a little like triangle out
Yeah,
of aluminum, and they set it on
yeah.
the sulfur hexafluoride, and it'll float for a few moments. If you remove the lid on that, because it's usually whenever I see it, it's in like an aquarium. Like they'll put it
Yeah.
in a glass box and they'll fill it up with sulfur hexafluoride. If you
Or a
take the
bucket
lid
or
off that
whatever.
sulfur, yeah. But the thing is, that sulfur hexafluoride is eventually going to move in all directions out of the container and diffuse with the air, with the rest of the air in the room. That sulfur hexafluoride is not just going to continuously sit inside the aquarium for all eternity.
Oh, I think
so
it will unless it's blown out
No,
by
it
some air
diffuses.
movement.
No,
No, it
it has
evaporates.
it has a slower diffusion rate than the air around it, but eventually it will all escape that container.
Yeah.
That's why,
Can I?
that's why you can't have a bucket of steam or a wheelbarrow filled with propane. That's why in order to have gas, that's why if you want your barbecue to work in the summer, you have to get a container filled with it.
I guess you guys
But
don't
why?
seem to understand why I'm making this point. And this is because the argument that the current model violates the second law of thermodynamics is one of our strongest arguments. It's very true. You can't have gas pressure without a container, right? Literally, it's the force or energy exerted on the walls of a container.
Yeah, why is that
Pressure, it
different?
presses on the walls of a container. It will fill
Okay,
the
but
available space. It will fill the available space. So you're actually undermining the validity of that argument when you give them this very ignorant argument on top of it that they can hone in on and just show that you lack fundamental understanding. So when you say proof that there is no downward bias, so you're going to say gas requires a container. We have gas pressure on the earth, therefore disproving the model because they claim that we're adjacent to a vacuum without a container that violates the second law. They're going to say, no, that's not true. There's a gradient. And you can say, well, that's a non sequitur, right? Because that's a quality of the gas pressure. That's delta X. We're talking about the antecedent of X. And then they'll say, well, it's gravity that's causing it. And if they're like, what is gravity? And then they won't know the difference between the two or whatever. So you're like dominating them so far, right? Just dominating that side so far. And then when they say, oh, well, gravity is causing a downward bias, pulling on the air or whatever. If you then say, that gas goes in all directions, and that proves there is no downward bias. They can then just take their victory lap and say, hey, look, the flat earther is so stupid that they think if something goes up or in all directions, that it automatically has no downward bias because they don't understand the principle of strength variance. The
Which if
difference in
something is
strength.
can
if
I ask
something
a
is moving,
question?
real quick, if
Go
something
ahead.
is moving freely in all directions, that literally means there is no directional bias. What is your problem?
Why do I have to keep
so
explaining this?
so I want to add in. I have to go because we have guests over, but I just wanted to say first of all, Vax, there's no need for cussing for swearing.
My
You did
bad.
that earlier. Um, Second of all, before I go, I wanted to say you're speaking to Austin. He has probably a lot more experience than any of you guys do in studying and in debating and everything. Experience that you guys don't have, and he also is like just visibly probably way more intelligent than anyone here on this call. So just make sure you guys respect him because he has a lot of experience and intelligence behind him. So, and he's been also been going through a lot recently.
We
so
talk
just
about
be
ideas
thankful.
and not people, please.
Yeah, like what?
Only
So now
they,
we have to like worship Witsit?
no, well,
I
thank you
have
for the
a
kind words,
question.
man. They're not going to receive that, but I do appreciate all the
My
kind
IQ
words.
is 160.
And
Like, who cares?
Look, I respect Witsit for getting on a plane for all those hours and spending all those days in Antarctica. That was a cool thing to do, and it's something that a vast majority of flat earthers don't seem to get off the couch. But like, I want to understand this downward bias thing better. Like, is there something that the theory of downward bias predicts better than the modern or even the conception of gravity from 100 years ago?
the theory of
Pre-Einstein
downward
gravity.
bias, what does that mean?
Yeah,
Your
you
model
use this term.
requires
You
the
use this
claim
term
that
downward bias as if it is a replacement for the effects that we refer to as gravity. I'm
no.
wondering, does your downward bias theory predict anything that we can observe better than the Newtonian conception of gravity?
Okay, so that's not what I do. I don't have to replace your belief system at all.
You literally
Falsification is
replace gravity with ether and electrostatics, Witsit. You're literally coming up with a gravity replacement. And all I'm saying is
no.
gas doesn't have a directional bias, and for some reason you think that's a bad argument.
All
Well,
right,
I'm asking him
I
if
just want to let you guys
if
know that
he predicts
only
something
people who
better.
can't actually win a debate have to censor the other side's arguments.
See, we're
Who
talking
did
about
that?
people again.
You
We're
just did it.
talking.
You just interrupted me. No, we're not talking about people again. We're talking about the inability to have basic decorum and intellectual discussion. That's what we're talking about, Marsh. We're talking about the
But
actual format of this discussion and how it's impossible to be fruitful if every time that you're trying to build a point or receive or get to a conclusion that it's interrupted with red herrings and diversions and deflections.
right, let's get back to it. Is there something that this concept of downward bias predicts better that we can observe? It predicts it better than the Newtonian concept of gravity.
Right. You remember that I was trying to answer that question a second ago?
Yeah,
So
go,
okay.
man.
So I don't have to replace your claims. Falsification is independent of replacement. I only acknowledge the downward bias in this conversation because I heard the same talking point that has been repeated by flat earthers for years that come from FED, who, if they realized they were wrong about this, they would never admit it. They can't. They have to claim they're always right. I'm trying to help them out. I'm not trying to
Wrong about
argue with you
what?
about about straw man's of my position. I'm trying to tell you guys that to say that there's proof there is no downward bias because gas goes in all directions is a very poor argument because, and just be honest, something could have a downward bias, but there could be another variable that overpowers that downward bias and it could go in all directions. I gave you an example of say a ping pong ball, more dense in the air, but I can make it levitate with acoustics. You're laughing because I'm giving you an analogy, but you're not addressing the concept. Do you agree that the ping pong ball has a downward bias in the air? Yes or no?
It's a ping pong ball gas, Witsit.
No. So the answer
Why?
is yes. The ping pong ball has a downward
No.
bias in the air because it's more dense than the air. That means it has a tendency to go down, has a
Does the
preference
air
and
does the
direction.
air have a downward bias?
Do you notice how they're never it's impossible for him to acknowledge this honestly, and it's like that with that entire crew, and it's so blatantly disingenuous. So
I'll agree with you. Like a
the
ping
ping
pong ball
pong ball goes.
is slightly denser than air, but they're filled with gas on purpose. It's
Yeah,
one of those
sure,
things that's like barely more dense than air, and it's good for
sure,
demonstrations of things like acoustic levitation.
exactly.
I'll agree with you on that.
That's why I changed
State
it
of
to ping pong
matter
ball.
than air.
So listen,
It's a
check.
completely different state of matter. A ping pong ball is a
That isn't the.
solid.
That isn't. We're not talking about that. We're talking about a principle, a concept that you are wrong about. And instead of engaging in the concept in good faith, you're using whatever tactic you can to just hand wave dismiss the point. If I drop a ping pong ball in the air, it's more dense than the air. It's going to go down because it has a preferred direction down, a downward bias. I can introduce another variable, such as acoustic levitation, and those sound waves will manipulate that medium. And since the variable is stronger than the downward bias of the ping pong ball in the air, I can make it go up, right? I can actually introduce the sound waves in such a way that I can make it go to the side. I can actually turn two different speakers on and make it go left and right, left and right. I can make it go at different angles. I can make it go up. I can make it go in any conceivable direction with acoustic levitation, depending on what angle I introduce the sound waves. Okay, so that proves this concept that I shouldn't have even had to try to prove, which is that an object can have a downward bias, but due to other variables that are also present, can still go in all directions. That doesn't
Yeah,
prove there is no
there's
downward
other
bias.
forces. There's other forces in addition to the downward bias.
Exactly.
Sure.
Very simple concept. So when flat earthers say the proof that there is no downward bias is that gases go in all directions, that is a very bad argument, because if there was another force present that was stronger than the downward bias, like the kinetic energy of the gas, if it's stronger than whatever that downward bias is, then it would go in all directions, even though there was still a downward bias present. Okay, so
Yeah,
please stop
wind
making that.
exists, for example. Wind is an example of kinetic energy of a gas.
Wind is
And
just
I'm
pressurized gas.
the reason that this is important is because it actually gives the other side an out. It gives them an out because the argument is so solid when it comes to the second law of thermodynamics. But it falls apart when you give them this out by saying that, like, the proof there is no downward bias is that it goes in all directions. And typically when that happens over there, they just mute you and they just repeat it and scream at it over and over and over, and they think that that's like this 100% home run gotcha. And I'm just trying to tell other flat earthers that actually operate in good faith, please don't do that, because it's just stupid. It makes us look bad.
Okay, I got you. So from now on, we shouldn't say gas moves freely in all directions, therefore gas has no downward bias. We need to just start saying ping pong golf ball to everybody. I got you. That's much better argument, Witsit. I totally agree. My
Yeah, but you
eyes are
know
open
that
now.
that's
I
that
see
you know that
right.
that wasn't my argument, and you're just disingenuous, and that's a you problem, and you can keep living in that cultish world where you can pretend that's what I said, but obviously the audience says that's not what I said. But this is what's the better argument that you should actually say, right? It's like gas disperses in all directions, omnidirectional. Everywhere you claim gravity is present, proving that this supposed force that is supposed to be strong enough to prevent it from doing that very thing clearly isn't doing that, right? That's the
No
actual argument.
shit.
Yeah, but that's not how you make the
Stop.
argument. You claim that there is not one present at all because things go in all directions. That is a terrible argument. I don't know how much more simple I could have put this to you. And if you don't
Listen,
understand it at this point, that is just a you problem, brother.
gravity doesn't have any effect on gas. Gas moves freely. Therefore, gravity's not a force. Everybody knows that. So how can something be a force if that force doesn't act on everything?
But gravity does have an effect on gas. This is measurable.
Doesn't. So now we're back to gas having directional bias.
Why is there a gas pressure gradient then, dude?
Oh my god. So you guys think that? So you guys think gas molecules fall back down to the ground at 9 meters per second per second?
Yes, they do.
That's what you're claiming. They do, really.
No, they don't.
Like any other molecules.
No, they don't.
Jesse
No,
has
they
a video.
don't.
Jesse measured it at home.
He measured
Measured
gas.
what?
He measured a gas molecule falling down.
It's
Really?
very simple. You get a vacuum chamber off of Amazon and an accurate scale, and when you pump the gas out of the vacuum chamber and you have an okay vacuum in the chamber, it weighs less.
So he didn't measure a gas molecule falling at 9.8 meters. Of course he didn't.
Well,
So
that's a different experiment, but he
no, that
measured.
experiment
He weighed
doesn't
it.
exist. That doesn't
What
ever.
kind
That
of
doesn't.
experiment?
That's a classic physics experiment.
It's
No,
not an
a
experiment.
classic experiment of a freaking gas molecule being measured to free fall. That doesn't happen.
Look at
No.
the design of high vacuum pumps. They put them at the bottom of the vacuum container because when the gas molecules are cold and it's a high vacuum, the molecules will literally like fall down to the bottom of the container and it sucks them out the bottom.
They still bounce.
Exactly.
around. They bounce around. Gas
Yeah,
molecules
they
bounce
do.
around. So
They
that
do a
okay,
lot. Yeah,
if
they're
a
like
gas
ping pong
molecule is
balls.
bouncing around, is it free falling?
It's a little of both. They're like ping pong balls where they bounce around a lot, especially at higher temperatures. But then if they get cold, they'll settle down towards the bottom, like ping pong balls.
But they're still moving when
Oh
they're
my
at the bottom.
god.
No,
Sure.
they're still moving at the bottom. Okay, so they're not free
I mean,
falling.
well, they are, but they also have other kinetic energy. There's a
No,
downward
then they're
bias,
not free
and
falling then.
it's some. Can't there be some of both? Like there are multiple
No,
forces. There are multiple forces that operate on things. We already established this, didn't we?
correct. But that means it's not free falling.
If a leaf it's a leaf in the wind free falling. I mean, there's
No,
the wind is blowing it one way and it's also falling to the ground.
no,
Everybody
it's
has
not.
seen this.
It's not free falling. That's what free
Okay.
falling means. Free of other forces. That's what free fall means.
Okay. Well, yeah, on Earth there's probably no place where there's absolutely zero other forces operating on things, although there have been physics experiments where they like drop neutrons and shit.
They drop
You know,
neutrons.
in a high vacuum. Yeah, this is one way they measure the gravity. They even do it with
The gravity.
anti-particles. It's
The
like
antiparticles are conceptual.
no, they make them in a lab.
I don't make them in a lab.
Well, I can dig up the papers and link them
So
if you
feel
want,
free
but
to do that
you'll
because I'm going
probably.
to school you on the neutron thing as well. So
Are you
the
interested in it? Okay.
yes, you can DM me. So
Give me a minute. I'll search them up.
yeah, no rush, brother. So neutrons, this is just so goofy. So every time I say, for example, that all like everything that exists is intrinsically electrostatic and everything that exists has a charge, you can't name one exception. You can't name one exception of anything in existence that doesn't have a fundamentally electric property, right? And then sometimes they'll say stuff like, what about insulators? So rubber and sand and glass. And I'm like, yeah, all of those things are intrinsically electrostatic. All molecular, uh, all intermolecular charges or attractive forces are electrostatic in nature. And on the
Yeah.
smallest scale, it seems at 36 power stronger than gravity's even claimed to be. So then they will move the goalpost to neutrons. They'll say neutrons don't have a charge. Neutrons are neutral. They're electrically neutral. And then I have to explain to them, wait a minute. They have a net neutral charge, but they are innately and intrinsically electric as well. Now, in this subatomic particle paradigm that I don't even believe in, we're going to step inside of it for a second. We have a neutron, and you guys claim they have constituent parts, right? It's comprised of quarks. And these quarks have elementary charges or fractional elementary charges. So that means that inside this little quote unquote neutron, there is still electric charge. So the fact that you say that we've gotten it pretty close to neutral, or neutrons are like as close to neutral as we can get as a net charge, doesn't mean it's not electric. It's intrinsically electric, right? Because they have elementary charges or fractional elementary charges. There is no exception. Everything that exists has vibration and electric properties.
Well,
Everything
what
exists.
term do you want to use for something with a net charge of zero?
Well, you can call
What
it,
should
you
we
can
call
call it
that if
neutral.
not neutral?
That is what we call it. We call it neutral.
So neutral things exist, and it's a net zero charge. So if it has a net zero charge and it's a single particle, no dipole moment, isn't that the same as saying it's just a neutral particle?
Well, no one said that you can't. First of all, I don't believe in any of these subatomic particles. They're reification fallacies. But the phenomena is real. Just your model is super fake. But that's not even the point. I never said that you can't call it neutral. I said you can't claim that it's always invoked as an example of something that isn't electric, and that is not true. It also is. There is no exception. When I say, can you name everything that exists? Everything
Can
that
I name
exists is
everything that
electrostatic.
exists?
No. All you have to do is name one thing that exists. Like name one piece of matter in the whole world that's not electrostatic.
Not electrostatic. So electrostatic generally refers to a charge imbalance, a net imbalance in charge. But the common reference we use here on Earth is, guess what? The Earth itself. We drive a copper rod down into conductive soil, and then anything that is even weakly conductive that we connect to that rod, like a copper water pipe or something, that is going to be, it's going to have a net zero charge compared to the Earth, which is, about as neutral as you're going to get in daily life.
No,
But you
it's
don't
well
want to
known
talk
that the
about
surface of the
neutrons.
Earth is negatively charged, quote unquote, and that the air is positively charged. And both of these are misnomers. It just means the process of charging or discharging. And then we do ground things into the Earth. Yes, that's because things seek equilibrium there, and they have plenty of space to have spatial discharge. They actually discharge and equalize into the Earth.
Yeah.
Yes, that's correct.
So
But the
say
Earth
it's
still
net
has a
neutral
charge.
relative to the Earth.
The entire Earth is held together by electrostatic charges. Like literally, that's the only way you even have Earth.
Okay, but you see, I think you shifted the conversation from talking
No,
about net electrostatic charge on macroscopic objects to, well, the charges exist and do things like, atomic bonds and chemistry and stuff like that.
no, I didn't shift anything. My whole point is that everything is fundamentally electric and that there are no exceptions. So when people want to talk about things like things falling or weight, and they want to make up stories of gravity that they can't define, and they claim that two opposing ideologies of gravity are somehow simultaneously true, and they just want to reify that concept. And then they ask me to replace it. I'm like, whoa, I don't have to replace any of that. Okay, you're making up, you have the burden of proof to support some of these claims that you're making. But what I'll do is I will point out what does actually factually exist. Density exists. So now it's like, okay, if an object's more dense than the medium, it goes down. If it's less dense than the medium, it goes up. So then if we're trying to wonder or figure out how that happens or why that happens, we would want to know, well, what is density? What's the cause of density? Okay, and density is the compactness of matter. So then the cause of density is whatever it is that is compacting the matter, that's holding it together with a certain compactness. And the answer to that is electrostatic charges. So then when someone wants to say, well, what is weight? Objects have weight, because that's what you're really asking when you ask me to replace your gravity idea, is that objects have weight, right? Gravitas
Okay.
means heavy. The word gravity literally means heavy, heaviness, weight. That's all it means. Little g just means heaviness. Okay, so let's look at the equation for weight. It is W equals mg. Okay, so weight equals mass times gravity, little g. So what is little g? It's downward acceleration, right? It's just the fact that things fall at roughly the same rate, 9.8 meters per second squared. It's just an agreed upon average. It's literally just a description of an effect. It just doesn't incorporate any cause claims at all. It's just saying it's sitting back with our clipboard, watching something fall and saying, hey, here's how fast it fell. We're just recording it, we're describing it. Okay, so that's just a quantified effect of how fast things fall on average. G. Okay, what is M? It's volume times density. So we got volume, right? Which is pretty easy to understand. It's just like, again, a mathematical description, the concept of the actual, like, the area and width, etc. And now we have density. So if mass is volume and density, what is density? Again, it's the compactness of matter. So what's the cause of density? It's whatever's actually holding the matter together with a certain compactness. So what we've now figured out is that the actual fundamental primary cause of that in that equation is electrostatics, because that's what gives the actual
This
matter
is super
compactness.
easy to disprove, right? Like you, the effects that we refer to as gravity are always attractive, whereas electrostatic effects are either attractive or repulsive, like charges repel each other. So if gravity were like super attractive, we would, and also were electrostatic, we would experience objects in daily life repelling each other. And I know
Actually,
that
a misnomer.
you can show examples with Tesla coil and bits of styrofoam or something super lightweight, super not very dense. But in daily life, like it's you cannot reconcile the repulsive forces of electrostatics or magnetism with the effects that we observe with gravity.
Yeah, that's actually a misnomer.
It's not a misnomer. I didn't name anything.
Dude, his
well,
point
you said you were talking about the effects of like attraction, magnetic attraction, and stuff like that.
Repulsion.
And the difference between repulsion and all this, and it's actually a misnomer that magnetic attraction exists.
Okay. Well, misnomer means something's named badly.
Dude,
Yeah, well,
maybe you're saying
it is
something
named
else.
badly. Yeah.
Dude, his point was that like you don't even get density without something holding the matter together, and you completely just sidestep that to talk about repulsion and attraction.
Well, electrostatics hold the matter together.
Also, it doesn't just mean naming something; it's designating something. So it can be a description as well. So you're wrong.
Okay, well, I didn't name or designate anything. I just described effects and why it wouldn't work with this idea of electrostatic repulsion.
No, you designated property. You described something improperly. It's a commonly held misconception in terms of the description. So he used the word properly. So we'll just move past the semantic pedantic diversion, and then you can maybe address the point.
Yeah. And I linked also real quick, I linked the article about measuring the effect of gravity on antimatter in the live stream chat, and I tagged you.
Okay.
Dude, if denser objects go down, and one of the variables which is causing an object to be dense is electrostatics, then it's a variable which leads to objects going down.
So denser objects do tend to go down, but it has to do with the amount of mass and not the amount of charge in the object.
Dude, I'm just saying that one of the variables which is contributing to something going down would have to be, logically, if you're accepting that the thing which is holding the dense object together as electrostatics, then that's obviously going to be a variable which is at play.
Mass and
There's
charge are
actually
two
a
different
formula
variables.
that can predict. There's actually a formula where you can predict if the
No, I'm
object's
going.
going to go up or down. Hold on 1 second. I'm almost done. There's actually a formula There's actually a formula where you can predict if the object's going to go up or down by dividing the density of the. You either divide the density of the object into the density of the medium, or vice versa. And if the number is higher than 1 or lower than 1, it'll tell you if it's going to go up or down.
Yeah, buoyancy, right?
Nope. I didn't say anything about buoyancy. Just a
It's
formula.
not buoyancy?
There's just a formula where you take the relative density between the object and the medium, and you can tell if it's going to go up or down. That's it. There's no gravity formula or nothing in there. It's just density of the objects. That's all you need to tell if it's going to go up or down.
Like, is this the formula you would use to determine if a helium balloon floats or something floats on water?
Yeah, it's the formula you would use to tell, but just from density alone, if something's going to go up or down.
That would actually be a formula known as the specific gravity formula.
That's a specific gravity formula. There's no little g in specific gravity.
It's in specific gravity, you're measuring the density of a given substance versus the density of water at 4 degrees Celsius. But you can take the density of water and create a relative specific formula as well.
Okay, what's the formula for specific gravity? Do you have it?
Density of a given substance divided by the density of water at 4 degrees Celsius.
So this isn't that, because that's not anything. That's not even what I said.
Jeremy, if you had listened to the rest of what it said you can create a relative specific gravity by changing the denominator from density of water to something else.
Yeah. So, okay. So
That
this
would be
is
the
not the formula. My formula is not the same as your formula. Do you recognize that fact? This is a different formula.
Jeremy, they're both specific gravity. You're just changing.
You don't
just one is.
this. You don't recognize.
All right, if you can't listen, I won't talk. Fuck you.
I think it's just a difference of
You're just not
naming
going to
here.
admit that. You're just not going to admit that it's a different formula.
So, but it's a ratio of the density of one substance to a reference substance, right?
The medium and the object.
The
Yeah.
medium, as you put it. Yeah.
Not water, not anything else. Just the two densities of the medium and object. That's it.
Yeah, like in chemistry, they reference it to a water at a particular temperature. Like different trades will have different specific terms, but so I'm looking at this on Wikipedia. They call it relative density or specific gravity. It's the ratio of a substance to a reference substance or a medium, like you're saying.
No, dude, we just went through it. It's not specific gravity. It's a different formula.
Relative density.
You guys, I don't know,
You want me
man.
to link the page? Okay, so what was the formula you were saying?
The density has nothing to do with water unless water is the medium.
Right.
It's the density of the object and the density of the medium it's in.
Yeah, Wikipedia agrees with
nothing
you
to do
on
with
that.
water unless water is one of the mediums.
Yeah, that's exactly what Wikipedia says.
For relative dense for specific gravity?
Relative density RD or specific gravity SG is a dimensionless quantity as is a ratio of either densities or weights. RD equals rho substance over rho reference, where RD is reference density, rho substance is the density, relative density is the density of the substance being measured, and rho reference is the density of the reference. The reference material can be indicated with subscripts. If the reference is not explicitly stated, then it is normally assumed to be water at 4 degrees C in SI units.
Yeah, well, I mean, usually in general terms, you can use specific gravity as the density of an object over the density of a fluid.
It's great. You guys can read out of school books.
Yeah, it agrees. I mean, I think you all are in agreement.
Jeremy,